All right, so we've got a deck of cards. And these are our four possibilities here: red, blue, orange, yellow. We have a card drawn out, and then it's replaced, and they already go ahead and tell us that this is experimental probability, right? So we don't know actually how the deck is uh, filled with these different color cards. Is it four equal sets of 10, 10, 10, and 10? Possibly, but that would be theoretical probability. Experimental probability is what actually happens when you do the experiment in the real world. You pull out a card and then you replace it 40 times. And as you can see, they didn't pull out the cards evenly, right? Orange was pulled out the most, blue was pulled out the least. So that's the difference between experimental probability, what actually happens, and theoretical probability, what should happen. So we're trying to find the experimental probability, right, using this data right here, of the next card being drawn, red or orange. So if I wanted to just put my possibilities here as a sample space, right? It's pretty simple. I've just got four options. I've got red, I've got blue, I've got orange, and then I've got yellow. Those are my four possible options. Assuming that they are evenly distributed throughout the deck, if we wanted a theoretical probability, right? Well, if there's literally an even amount of each, right, we might say 1/4. But we're not dealing with the theoretical, we're dealing with the experimental. And so what we have here is we need to take a look at how many times was red actually pulled out, right? That's 9. How many times was orange pulled out? 13. Okay? When we're dealing with this word or, that means it could be either red or orange. And so when we're dealing with red or orange, and it's just one simple pull. So this is going to be, that's next card. So this lets us know this is what we called simple probability. You're not doing one card, then replacing it, and then trying to grab another card. That would be compound. If you draw a red, replace it, then draw an orange. That's a compound probability. Simple probability is just you're just doing one event, pulling one card. So if it's red or orange, we can actually combine those two. Okay, so what we're going to do is we're going to just set up a fraction like this. It's going to be red or orange. It's going to be my numerator. And then my total. Right, your denominator is always going to be your total. And that's going to show you the probability. So my red is 9. My orange is 13. We've already said that since you've got this word or, if it can be either one, that means we need to add these two. All right, so we get 9 plus 13, and then that's going to get me over. I could add those if I really need to, but they already tell me it's out of 40 times, right? That's going to be 17, and that's going to be 23, so that's 40. But if you need to, you can go and add them up. All right, so it's going to be 9 plus 13 over 40, so we can simplify that. 9 plus 13 is 22. And if you see that, you should be thinking, I don't see the answer. That's fine. The one complicated, if you want to call it that, part of this problem is you are going to need to simplify. Whenever you see a fraction, your first question is, can I simplify? Because you're always going to need to be able to show it in simplest form. Those are both even numbers, 22 and 40. So let's divide by 2 over 2 to generate an equivalent fraction. And there we go. Now we're going to get 11 over 20, and that is going to be our answer C, 11/20.